Okay, here's a really short walkthrough of some of the example problems for the sheet you have today, going over that formula we found yesterday in class. So we're going to do short answer 1 and 6 and the math 7, 9, and 14 together. So number 1, does the speedometer of a car read average or instantaneous speed? Now the speedometer, when you look up at it, only tells you the speed you're going at that moment. It doesn't tell you the speed you're going on the whole trip. So it is telling you the instantaneous speed. The average speed is what you'd find from our formula from last unit, distance over time. And some of your newer cars do have a button where you can find that as well. So number 6, if you go down to here, describe a situation you can accelerate even though your speed doesn't change. So let's look at the formula. Acceleration is change in velocity, not change in speed. So there's 3 ways you can accelerate by changing your velocity. You can increase your speed, you can reduce your speed, or the difference in velocity and speed again is direction, or you can turn. If you change direction, every one of you have been in a car where you felt that when you go into a tight turn, even without slowing down or speeding up, you feel the acceleration. So you change direction. On to the math. 7, let's walk through the experiment we did yesterday though. We let that car roll down a ramp, and as we gave it more and more time, we recorded the speeds that it got to. And it made a pretty straight line as long as we kept the ramp at a constant angle. And then that is a line, which means it has a slope, and the y over x, y was delta v, change in velocity, and x was t, time. So the slope, the relationship, we gave it the name acceleration this time. So it's always the same thing. Every one of our formulas. Find a connection between the y and the x. If it makes a line, it has a slope, and that slope is the relationship. It says how much the y goes up as x, how much the dependent variable goes up with the independent variable. So we got that formula. We can put it into a triangle. The delta v is over the t. So I'm going to put the a in the last spot. Delta v over t, delta v over t. It's set up correctly. So this is the information they gave us for this one. And you do not have to show any of this. You're just looking at this last part. So we want to know acceleration. So the formula is delta v over t. Show me my formula. Do the substitution. Change velocity went from 4 to 22. And so it went from 4 to 22. That change is 18 meters per second. If you like formulas and you need them to find change in velocity, it's always your end minus your beginning. Final minus initial. That's what the F and the I stand for. T right here is 3 seconds. So my acceleration, 18 divided by 3 is 6 meters per second per second. Again, which means every second you're changing your speed by 6 meters per second. Usually you'd see that written as 6 meters per second squared. Very few people will write it like this, but I think it makes more sense to you. I'll, of course, accept it either way because they're exactly the same thing. Moving on. Number 8, we're not going over, but I did want to stress that this does have to have you answer it twice. Find the acceleration of the bike, find the acceleration of the car. Then we get to number 9. We're looking at a car, 70 kilometers per hour. It's not meters per second this time, but it doesn't matter. Starting at rest, though. Rest is 0 in any unit. So I put it as 0 kilometers per hour, and there's our information. So once again, we're looking for A. A is delta V over T. Formula, substitution, I went from 0 to 70. So my change in speed is 70 kilometers per hour. And I did it in 7 seconds. So the number is easy. 70 divided by 7 is 10. But the unit, you got to think through the unit a little bit. 10 kilometers per hour per second. And again, this makes a lot more sense now that we know what that per means. It means every second you're speeding up by 10 kilometers per hour. So if you went 60 seconds, you'd be 600 kilometers per hour. So it would just tell you that. So skipping on to the last one we're going to do together. And that is right here at 14. This one is the same exact formula. It's just put in a slightly different order. So we got the same formula, still delta V over T. Still A in the last spot, and this time we're looking for change in velocity. So delta V is going to be T times A, and our t was 3 seconds. Doesn't matter the order. If you put it the other order, it's just as good. 50 meters per second, or 50 meters per second squared. That's going to leave us with 150 meters per second is the change in speed. But that's not what it's asking for. It's asking for the final speed. We started at 10. So imagine this like a bank account. You start with $10, you add $150, so you're going to end up at 160. There's no difference here. You're going to end up at 160 meters per second. Because we started at 10, we added 150, so we're going to end up with 160 meters per second.